prove that integral of under root of a square minus x square dx is equals to x by 2 into under root of a square minus x square plus a square by 2 into sine inverse of x by a plus the constant. So this is very important, one of the important results. So this can be proved in two different ways, one of which is the integration by parts. First of all, let I is equals to integral of under root of a square minus x square dx. You may use the substitution x is equal to a sine theta and then make the corresponding changes, but we will use here the integration by parts by taking 1 as a second function, a square minus x square. I will take 1 as a second function, and now integrate by parts. The formula for parts is like this: integral of u v dx is equals to u into integral of v dx minus integral in bracket the derivative of u into the integral of v and again this dx. So in this case this is the first function u and this is the second function v, and now I will use this formula for parts, which is equals to first function means under root of a square minus x square into the integral of second means the integral of 1 dx, which is nothing but x, then minus integral, I'll write in bracket the derivative of first. The derivative of first means derivative of under root a square minus x square into integral of 1 dx. The important thing is to use this formula in proper way by selecting the first and second function. So in this case we are choosing this as u and this as v, and I have this formula here. Now be careful about this derivative. Other things are very easy. So this is equals to, see now, under root of a square minus x square. The integral of 1 is known to you, it is x minus. So this is the important thing, the derivative. Use the chain rule for finding the derivative of this. I will show the derivative, how to find the derivative of this. So to find the derivative of this function, you should know the derivative of under root of f of x. You should know this formula, the derivative of root f of x, which is 1 upon 2 under root f of x into again the derivative of f of x, that is f dash of x. So using this formula I can find the derivative of under root of a square minus x square like this. Here I will show the derivative of under root of a square minus x square, the derivative of under root of a square minus x square using the above formula. In this case this is your f of x, this one is your f of x. So using the above formula for derivative of root f of x, I can write this as 1 upon 2 under root of a square minus x square into f dash of x means the derivative of this f of x, which is in this case a square minus x square. Take its derivative. The derivative of a square is 0 minus that of x square is 2x. So this will become minus 2x. So this is the derivative of under root of a square minus x square, which I have to write here. So I will use it there. The derivative of under root of a square minus x square, I have shown it, which is this one, 1 upon under root a square minus 2 under root a square minus x square into minus 2x. So that is the derivative. See, I will use it here. integral of the derivative of this term I have shown here. So in that 2 can be cancelled. So this is the derivative. Okay, then I have taken the derivative of this under root a square minus x square like this into the integral of 1 dx is x. Is that clear? Then this 2 and this 2 get cancels. Okay, here in the numerator there is minus x into x means minus x square. So I can write this as x into under root of a square minus x square. This minus outside as it is. Integral in the numerator is minus x square divided by under root of a square minus x square dx. Now I have to integrate this thing. So for that I will express this numerator in terms of a square minus x square so that I can separately divide them. LHS is nothing but under root of a square minus x square. Now I would like to express this numerator in terms of a square minus x square and see what you get there. If I write this is equals to x under root of this as it is a square minus x square minus integral. Now I want to express the numerator in terms of this a square minus x square. There is minus x square already, so I just need to add a square. So I added here a square, so I should subtract a square again dx. Very easy. So this is equals to further x under root of a square minus x square. You can separately divide now this a square minus x square upon under root a square minus x square. It will look like this: a square minus x square upon under root of a square minus x square dx. This minus into this minus will become plus a square upon, I'm just separately dividing and integrating both the terms separately. Now the numerator can be cancelled. You should know that x upon root x, if I divide x by root x, we get root x. So in the same way here, I can divide this a square minus x square by its square root. If I divide any number by its square root, I will get the square root of that number. Means like this, x into under root of a square minus x square. Now using this result, if I divide this bracket in the numerator by its square root, I will get a square root of that. It is x by root x is root x. So in the same way, if I call this as say x, then this will be root x, and x upon root x is root x. Okay, now dx as it is. This numerator a square can be taken outside, it is a constant, and there is a formula for under root a square minus x square, which is simply sine inverse of x by, I know the integral of 1 upon under root a square minus x square. I will call this as some constant of integration c1. The left hand side is I, which is nothing but integral of under root a square minus x square. This is equals to x under root of a square minus x square. This one is I, and this is again I, which we have supposed here. This one, I may give this number 1. So this is integral under root a square minus x square is I. So I have put here I. Then further plus a square into sine inverse of x by a plus the constant c1. Now take this minus I to the left side. Take this minus I to the left side, it will become I plus I, which is 2I, and that will give you the answer x into under root a square minus x square plus further a square into sine inverse of x by a plus c1. Now divide 2 out by 2 and it will give you the required answer, x by 2 under root of a square minus x square plus a square by I'm dividing by 2 on both sides, and that is the final answer. C1 by 2 is nothing but C. That is your final answer. C1 by 2 you call it as C. I is nothing but integral under root of a square minus x square. The conclusion now. Just I is under root a square in the integral of under root a square minus x square. So it gives me the required result. That's all. Therefore, integral of under root of a square minus x square dx is equals to x by 2 under root of a square minus x square plus a square by 2 into sine inverse of x by a plus c1 is a constant upon 2 is a constant, so I may call it as c, where c is nothing but c1 by 2. Isn't that? Now we'll see one more example. Oh, sorry, one more theorem here. It is under root of integral of under root of x square minus a square. See one more result. Theorem number next. Prove that the method of proof is again same. Integral of under root of x square minus a square dx is equal to x by 2. The same procedure, under root of x square minus a square minus further a square by 2 log of x plus under root of x square minus a square plus c. I'll follow the same step here. First of all, let I the integral and then taking 1 as a second function, we will integrate by parts. See the proof. Let I is equals to integral of under root of x square minus a square dx. Take 1 as a second function, so this will be equals to integral of under root of x square minus a square into 1 dx. So as in case of the previous result, this is your u and this is your v. So by formula, u into integral of v dx minus integral of the derivative of u, the derivative of first term, into the integral of second and dx once again. So that is equals to under root x square minus a square, the integral of 1 dx is x, minus integral of the derivative of this, it is by chain rule 1 upon 2 under root of x square minus a square into the derivative of x square minus a square is 2x, and the integral of 1 dx is x, and this dx as it is. 2 get cancels and we are left with x under root of x square minus a square plus the numerator is now x square divided by under root of x square minus a square dx. Okay, so now I will call this is again I. It is equals to x under root of x square minus a square plus. Now I'd like to express the numerator in terms of the denominator. Means express this x square as x square minus a square plus a square, because there is only x square and I need x square minus a square, so I written like this. It's complete divided by under root of x square minus a square dx. Something is wrong here. This was the minus sign. Here is the minus sign. Okay, so I should make the correction here. This is again minus. Now separately divide and then integrate. So this is equals to x under root of x square minus a square minus x square minus a square divided by under. I'm separately dividing, then minus a square upon under root of x square minus a square dx. The middle integral I can write as x upon root x is root x. Likewise, in this case, this will be under root of, which is your LHS I, and the last integral is known to you. A square is a constant, take it outside, and this is nothing but log of mod of x plus. There is a formula for 1 upon under root x square minus a square. The integral of 1 upon under root x square minus a square is like this. Plus again some constant, say new constant, I'll take it as C1. On the left hand side is I, and on the right side also this is I. So x under root x square minus a square, this one is I, minus further a square into log of mod of x plus under root of x square minus a square plus C1. Now take this minus I to the left side, it will become 2i, which is x under root of x square minus a square minus further a square into log of mod of x plus under root of, isn't that? This is your C1. Now divide by 2 and that is the final answer. I means the required answer. X by 2 under root of x square minus a square minus further a square by 2 log of mod of x plus under root of and C1 by 2. I am dividing by 2. So C1 by 2 is nothing but a constant. You may call it as C. C1 by 2 is again a constant, so we will call it as C. And that will give you the final answer. That will give you the final answer. Conclusion: I is equal to x by 2 under root of x square minus a square minus a square by 2 log of mod of x plus under root x square minus a square plus C1 by 2 is C. C1 by 2 is nothing but the constant C. So that is the second result. In the same way, one can prove the formula for under root of x square plus a square. The similar steps you may get like this. If you use the same steps, then you will get the third result. You can prove it yourself. Prove that integral of, in the same lines we can prove this result. X square plus a square dx is equals to x by 2 into under root of x square plus a square plus further a square by 2 log of mod of x plus under root of x square plus a square plus c. It's the result which can be again proved using the same technique.